Student here at Penn State, and he is going to tell us about the upcoming solar eclipse and hopefully encourage everyone to go see that. So I will be dropping by while he gets everything set up here.
Hello. Okay, everybody. So I just wanted to start this off just with a show of hands. How many people are aware that there is a total solar eclipse next month? There are a lot of hands here. Maybe I don't need this talk. But for anyone who didn't know or wants a little more information, that's what I'm here to do. So I'm going to dive right in here. So first of all, there it goes. Total eclipses, total solar eclipses, are pretty rare events. They really only occur on very narrow regions of the Earth. This map here shows sort of all of the eclipses, solar eclipses that have taken place since between 2001 and 2020. The blue ones here are the total solar eclipses. The red ones are something slightly different that I'll explain just a bit about later. But so you can see there aren't very many blue ones here, and all of them are pretty narrow. So if you're in one spot on the Earth, chances are you're probably not going to ever have one of these come across your way. So they're pretty rare. So why are they rare? And what is a solar eclipse? So here's a good diagram of the sun, the moon, and the Earth, obviously not to scale. So what we hopefully know is that the moon orbits the Earth once every 28 days. This is the lunar cycle. As it's shown here, the moon is in new moon phase. That means we're just seeing sort of the shadowy portion of the moon, and if it were on the opposite side, it would be the full moon. It would be big and bright in the night sky. As it is right now, it's dark and comes up roughly at the same time as the sun. So what happens is, if you're in sort of a special alignment, the light from the sun gets blocked by the moon, and you get this nice shadowy circle on the Earth. And then as the Earth rotates, you get those little paths that we saw in the first map that I showed. So we know that the moon orbits the Earth once every 28 days, so you might ask, why don't we get a total solar eclipse every month? The reason for this is the moon's orbit is tilted, so it's not perfectly aligned, and so most of the time the light from the sun hits the moon and it casts some shadow that just misses the Earth, and so we don't get a total solar eclipse. But in the right alignment, we do, and that happens not as often. So if you're in that area where the shadow from the moon falls on the Earth, this is a total solar eclipse. You can get something called a partial solar eclipse, and this is sort of in a band that's much wider than just the narrow shadow that the moon casts on the Earth. It's a band, spreads wider, and what you sort of see is just kind of the moon eating away at the sun, so sort of a circle kind of bitten out of the sun. And so this is a partial solar eclipse. One of the biggest sort of coincidences in astronomy is that the Earth, the moon, and the sun are roughly the same size in the sky as viewed from Earth. And so this is essentially what allows us to have total solar eclipses. The moon is big enough to block all of the light from the sun. However, sometimes the moon is a little further away in its orbit, and so it looks just a little bit smaller, and so it's not quite able to block all of the light from the sun. And so what you get are these really cool things called annular eclipses, and you get sort of this like ring of fire. And I like to imagine if you're like some early civilization hunter-gatherer going around, and all of a sudden you just happen to be in the right spot at the right time and see one of these. I would be pretty terrified, to say the least. But luckily now we know what these things are, and so we don't think that apocalypse is coming or anything. Just some really cool annular eclipses. I think these ones are cool, but this isn't what we have next month. We have a total solar eclipse. So what makes next month's eclipse so special? Basically, it's sort of just a normal total solar eclipse, except it happens to just go across the entire US, and so that's what makes it special. It's an eclipse across the USA. This sort of dark shaded path here is the path of totality. If you go somewhere along this path, that's where you'll see the total solar eclipse. The other thing that's really cool about this eclipse is that these lines, sort of red, they might be hard to see, but they're sort of parallel to this shaded path, and this is sort of indicating 90, 80, 70% coverage. So if you're somewhere along this line, you would see 80% of the sun's light blocked by the moon. And even that's something pretty spectacular to see. But this path of totality is super cool. You might notice that Pennsylvania is not in the path of totality. So if you're stuck here, this is more like what you'll see. It's roughly 70-ish, I think, percent coverage, and this is still pretty cool. So don't be too bummed if you're here. I would definitely recommend, though, visiting the path of totality. So we'll have links for like the maps and things. Definitely plan some sort of trip. But I'll point out here, it sort of begins to happen. So the moon sort of moves into the sun around 1:15. You get this view somewhere around 2:36, and then at about 4 p.m. it's moved off of the disk of the sun. And I will especially highlight that this is in the afternoon. A lot of times astronomers are saying, hey, go look at these cool events, and you wake up, you know, at 11 o'clock at night, or you go to bed early, wake up late at night and go look someplace dark and see something cool. This is in the afternoon. The sun is out. The moon is blocking the sun, so the sun has to be out in the sky. This is during the daytime. I had a few friends that I was telling about the eclipse. They live in Seattle, and they were making plans. I checked in with them a month later, and they were getting all excited, trying to find dark skies to go visit the thing. So I had to just check in with them and say, hey, you know what it is you're looking for, right? And so they got that figured out. But yes, afternoon, not nighttime. If you do go into the path of totality, you'll see something really, really cool. I have not ever seen it, so I can't speak for how cool it actually is. Maybe someone in the audience has seen it, but this is what you will see in the total solar eclipse. You see sort of the furthest most reaches of the sun's atmosphere in sort of this crown-like structure. This is the corona of the sun. It's very hot, very thin. I'm told, again, it's infinitely better than seeing a partial solar eclipse, so definitely try to see this if you can. But if you can't, I do have some warnings here now. So you're perfectly fine to be outside. It's just like any other day. You don't have to worry about being outside or being exposed to things. However, it is not safe to look directly at the sun without protective eyewear or other precautions. And I will repeat that. Do not look directly at the sun. Don't look at the sun with a camera. Don't look at the sun with binoculars. Don't look at the sun with the telescope. The only exception is if you have some specially made solar filter, and chances are you probably don't have one of those lying about. But if you do and it's made specifically for your device, then you're good. But otherwise, you probably don't. However, there are these super cool things called eclipse glasses, and they are made especially for viewing eclipses. And so we have some here. You're welcome to take some. They're free. They're incredibly fashionable. You can see all these happy children looking at the eclipse. So yeah, please take some. Take some for your friends. And yeah, I think I'm running out of time. But I'll again say, try to visit the path of totality. It's not the end of the world if you don't. There are events happening here with the Penn State Astronomy Department. They'll be hosting some events. We'll post links for those on our Facebook. I think the Penn State Astrofest will have links, but please check in on our thing. If, at the very least, maybe write this down, because this is sort of where you have the main sort of gathering of all the information related to the eclipse, eclipse2017.nasa.gov. There's a lot of good information there, maybe too much information, but yeah, it's great. That's all I have to say. I think I will then take a question or two, I guess.
I'll just point out that you don't need to wear glasses during the actual totality.
Right, yes. Yeah, for the like 1 to 2 minutes that it's actually in totality with the, I had the picture here, then you can take off your glasses. Thank you, I was going to mention that and forgot. But it's one of those, like, you wait until it doesn't look bright anymore with your eclipse glasses on, and I think like you turn away and then like look back again. I don't know, this is still all kind of new to me. So.
I read that the moon is about 400 times smaller than the sun, and it just happens to be 400 times closer to Earth from the sun, thus making it the same size in the sky. Does that seem alarming at all? Like, does it just seem like coincidence, or does that seem like design?
As far as I know, coincidence. Sorry, the question was about the sun and the moon both appearing the same size.
From our perspective.
Yeah, I think it's, I mean, the moon is slowly moving out, so, you know, come ask the Earthlings in, you know, 1,000 years or so. They'll probably only have annular eclipses or something. I don't know.
It's just like 500 million years more annual eclipse, or you get total eclipses for another 500 million years.
Total eclipses for another 500 million years. Mark your calendars.
Alright, so we're going to have a 10-minute break here. We'll grade your answers, we'll have a winner for trivia, and then we'll hear from Jason. So take a few minutes to put in another drink order, put in another food order, and we'll be back in a few.